Welcome to Flutter Basic Training. By the end of this video, you'll be shipping apps on iOS, Android, the web, and desktop.
You will not laugh. You will not cry. You will learn by the numbers. I will teach you.
Flutter is quickly becoming the world's most popular cross-platform framework, thanks to its awesome developer experience and ability to ship high-quality apps on multiple platforms. It's unlike anything else out there, which also means that it has a steeper learning curve. To get good at it, you'll need to stop watching YouTube and start building something. I created a bunch of satisfying examples that we'll go through together, designed to make you a productive full-stack Flutter developer. There are certain things they don't tell you when you first get started, like it's 100 times faster to refactor your code by hitting Control period than it is to do manually. We'll look at a ton of productivity boosters like this, and at the end of basic training, I'll give you a certificate that you can frame on your wall. And if you want to go beyond the basics, I just released a brand new Flutter course available to pro members on Fireship.io. There's an ephemeral discount in the video description. To get started, you'll need to use the most important skill for any developer: following directions. Head over to flutter.dev and follow the install instructions for your system. Or if you want an easier way to get started, Dartpad allows you to edit and run Flutter code in the browser. Now open the terminal and create a new project by running flutter create. Now open it in VS Code and make sure to have the Flutter extension installed. At the bottom, you'll see an option to select a device, like Windows, Chrome, or a mobile emulator. I'm going to run my app in Android by running flutter run from the command line. Now find your application code in the main Dart file. Read in between the lines to find a color or icon in your UI. Change one of these values to something else. You'll notice that when you type after the period, everything is auto-completed in the IDE. Tooling is partly what makes Flutter development so productive. If you don't leverage it, you are not going to survive basic training.
If you survive recruit training, you will be a weapon.
Save the file. Now type a lowercase r into the terminal. That performs a hot reload, allowing you to instantly see the changes in the UI without having to rebuild the entire app. Now take all the code in this file and delete it. We're going to start from scratch. First, import the Flutter material package at the top. This gives you access to hundreds of pre-built widgets in your code, ranging from low-level building blocks like text to complex UI elements like a page view that performs animation and layout. As a Flutter developer, you'll need to learn how to combine these widgets together into a tree-like structure to create a complex UI. But first, we need a main function. This is where the program will start executing. Flutter has a global function called runApp. It takes a single widget as its argument and will inflate that widget to the screen on whatever device it happens to be running on. Let's create a custom widget to represent the application. Type st into your editor and it should automatically give you a snippet for a Flutter Stateless Widget. Hit tab to insert it, then give it a name like my app. Notice how this class extends a stateless widget. That's a class built into Flutter that you use when creating a UI element that doesn't have any internal data. In other words, it's just a dumb widget that paints some pixels to the screen. You'll notice it has a constructor with a key. You don't need to worry about that for right now, but if you hover over it, you'll notice that it has a link to a YouTube video explaining more, because Flutter's documentation is absolutely awesome. The thing you do need to know about is the build method. This method returns a widget and will be called anytime Flutter needs to rebuild the UI, like when your data changes. The first widget we'll return is a material app. It's used as the root of the application and allows us to configure themes and routes. Perform a hot reload and you should have a blank canvas to work with. We can quickly add a screen to it by adding a scaffold to the home property. A scaffold allows you to build screens with common UI elements, like an app bar at the top. Every pre-built widget has a bunch of named parameters where you can customize its appearance. Put your cursor inside a widget, then hit Control Spacebar to bring up all the options. Go ahead and add a background color, then add a title by creating a text widget. Now hot reload to check out your first Flutter screen. That's pretty cool, but there's no time to celebrate. Now we need to talk about layout, or how do I put widgets where they need to go in the screen. The most fundamental way to lay out a widget is with a container. It's kind of like a div in HTML or a view in Android. It takes one child widget as an argument. We can make that a text widget for now, which will place it in the top left corner of the screen. You can think of it being surrounded by a box, and we can change the dimensions of that box by adding margin and padding. We can also customize things like the height, width, and color. We can also make the box look a lot cooler using the decoration property. It takes a box decoration widget as its argument, which allows us to customize things like the border, gradient, shape, and shadow of the box. Containers do a lot, but Flutter has some other widgets that are more focused. For example, if you just want to center a widget in the middle of the screen, you can do so by wrapping it with center. Now, you could write that code manually, but if you want to have a good time, you'll right-click on the widget or hit Control+ to find the refactor tool, then select the option to wrap with center to write that code for you automatically. Another tip is that if you're using a container to apply some padding, use the padding widget instead. Or if you're creating a container with a fixed width and height, use the size box widget instead. But how do we deal with multiple related widgets like a row or column? That's where Flex Layout comes in. If you're familiar with CSS Flexbox, you'll be way ahead of the game here. Flutter provides row and column widgets used to lay out multiple children horizontally or vertically. Unlike a container that takes only one widget as a child, a column takes multiple children as a list. Create a column, then add 3 icons inside of it. You'll notice that each icon is laid out one after the other vertically. Change that widget to a row, and now they flow horizontally. The direction they flow is called the main axis, while the opposite direction is the cross axis. You can change the spacing and alignment between the children by modifying the cross-axis and main axis alignment on the widget. By default, each child has a flex value of 1, which means that each sibling occupies the same amount of space. If that's not desirable, you can wrap a child in a flexible or expanded widget. Expanded tells a child to take up any available space, and you can give it more space than the other children by modifying its flex value. But in some cases, you may want to have one widget overlap another, like a button that floats on top of some other UI element. In that case, the widget we're looking for is a stack. Just like a row or column, it takes a list of children as an argument. And just one little side note here, you'll notice that I'm using a trailing comma after every block of code. The comma is not required, but it keeps your code nicely formatted. If you right-click and choose Format Document, it will format it with multiple lines, as opposed to one line when the comma is missing. Now in our stack, we might have a container and an icon. If we want to display the icon on top of the container, we make sure that it comes after the container in the list. Now if we want to move things around, we can use positioned to move a widget into a specific spot, kind of like absolute positioning in CSS. Or if we want to modify its positioning relative to its parent, we can use align to move it to the top, left, bottom, right, or center. Those are your low-level building blocks for layout, but Flutter takes care of many UI elements out of the box. For example, if we add a floating action button to our scaffold, that button magically appears down here at the bottom right. The floating action button widget has an event handler called onPressed. We can define an anonymous function here to handle the gesture. If we then want to add a bottom bar to it, we can use the bottom bar widget to add some navigation icons to the scaffold. We also need a drawer that animates out from the left. We can achieve that by simply adding a drawer to the scaffold. That's pretty awesome, but eventually you'll lay out your widgets and they will overflow the bounds of their parent, which will summon the red screen of death, or this black and yellow error tape. When you get an error like this, the terminal output will link you to Flutter's built-in debugger. That'll give you more information about layout to help debug things like this. In this case, the problem is that our parent is not a scrollable view. Things don't just scroll automatically. Instead, you need to use a widget like ListView. It takes a list of children as its argument, but will scroll between them. It can scroll both horizontally and vertically, and you can even tell it to garbage collect items that are no longer on the screen. You'll notice that in this list, we're adding each widget individually, but in real life, you'll often need to fetch a bunch of items from a database and then create each list item programmatically. In Flutter, many widgets can be built dynamically using builders, which is just a function that you define that can map a list of data to a list of widgets. And that means you can create a scrollable list that is infinitely long, where the children are rendered lazily, keeping the UI smooth and fast. Now that you know how to build a UI, we need to talk about state, or the data that changes throughout the lifecycle of the app. A stateless widget has no state, as the name implies. To give this widget mutable data, we need to convert it to a stateful widget, which we can do by right-clicking, going to the refactor tool, and choosing the option to convert it. That will break the widget up into 2 different classes. That keeps the widget itself immutable, while giving us a state class where we can play with mutable data. It has a build method, but we can also define variables on this class and then change them by using the built-in setState function somewhere else in our code, like when a button is pressed. We can create a counter app by defining a property called count, then reference the value in the UI using a text widget. When working with strings in Dart, you can interpolate a variable inside of it with a $sign. Now when our button is pressed, we call setState to change the value, and the widget will automatically re-render to reflect the latest data. Another thing you might want to do in a stateful widget is initialize data, like maybe fetch a record from a database. The initState method is called once when when the widget is first initialized. And there's also another lifecycle hook called dispose that runs when the widget is removed from the UI. Now you should know that this is not the only way to manage state in Flutter. In fact, there are many different approaches and many strong opinions out there about this topic. In my full course, I use a package called Provider that allows us to share real-time data throughout the entire widget tree without ever needing to use a stateful widget at all. There are also full-blown solutions out there like Block and Qubit. The full course also contains a repo of the same app built with Qubit. I want to give a shout out to Raleigh Perez for putting that demo together. If you're looking to hire a Flutter developer, you'll definitely want to get in touch with him. Now that we have a fully functional counter app, the question becomes, how do we navigate to a different screen? Well, confusingly, Flutter has Navigator 1.0 and 2.0, and all you need to know for basic training is 1.0. At this point, go ahead and build 2 different stateless widgets. Then give each one of them a scaffold. Make sure that each scaffold has an app bar at the top. In the first page, go ahead and add a button to the body of the scaffold. Now think of your navigation like a stack, where you can push and pop different screens onto it. To add a new screen to the top of the stack, we use Navigator push with the build context, then create a new material page route. The route expects a builder function, which then returns the screen that you want to render, which in our case will be page 2. Now do a full restart of the application by typing a capital R into the command line, and you should be able to navigate back and forth between the 2 pages. One magic thing that Flutter is doing here is adding a back button to the app bar, which under the hood is calling the Navigator pop method. That was easy, but I want to finish things off with something really cool. Flutter has a hero widget that can animate elements from one screen to another. So check this out. On page 1, I have an icon button with an image as the background. Then on page 2, I'm showing the same image taking up the full screen. That works, but I think we could do a little better. The magic comes into play when I wrap these images in a hero. The only argument the hero needs is an ID to identify it when it gets animated to the other page. Flutter will use the ID to keep the image in the UI on both pages while the navigation is taking place. Now on the other screen, we'll also use a hero widget with the image inside of it. When we navigate to this route, you'll notice the image itself is animated between the 2 screens automatically. It makes the biggest impact when you have a list of images to navigate to. Not only does it look awesome, but it would be extremely difficult to implement from scratch. Congratulations, you just completed basic training for Flutter. Take a screenshot of the certificate and frame it on your wall. If you want to go beyond the basics, become a pro member at Fireship.io to get access to the full Flutter 2 course.